GATE 2019 Civil Engineering Set 1 Question 44. Consider the ordinary differential equation x square d2y by dx2 minus 2x dy by dx plus 2y equals 0. Given the values of y1 equals 0 and y2 equals 2, the value of y3 rounded off to 1 decimal place needs to be found. The relevant NPTEL reference has been cited. Coming to the useful data for this problem, if we are given a differential equation which is x to the power n d to the power n plus x to the power n minus 1 times a constant a1 into d to the power n minus 1 plus x to the power n minus 2 a2 d to the power n minus 2 and so on till an, this whole term multiplied with y equals 0. So here we cannot use the standard techniques to solve this ordinary differential equation because the coefficients of the derivatives in the left hand side have the term x. So here we use a simple substitution using the Cauchy-Euler equation. We substitute x as e power z. When we use this, we will have to change these terms which are in the form of x and d. So one such example can be shown as if x equals e power z, if we take natural log on both sides, z would become ln of x. So if we need to find dy by dx, that would be dy by dz into dz by dx. dy by dz can be written as a new derivative term theta and it will be operated with y. So here d by dz has been changed with theta. This will be multiplied with dz by dx, that will be 1 by x, as the derivative of ln x would be 1 by x. This is equal to the derivative of y, that is dy. This would give theta y equals dy into x. So it can be written as theta as dx. Similarly, if we have d square x square, we can express it as theta into theta minus 1, and d cube x cube can similarly be expressed as theta into theta minus 1 into theta minus 2. So when we use this substitution, we should also change the derivative terms in this manner. So the differential equation that has been given is x square d square minus 2xd plus 2 times y equals 0. The initial conditions that have been given are y1 equals 0 and y2 equals 2. So we use the substitution where we put x as e power z. This would ensure z is natural log of x. So x square d square can be substituted as theta into theta minus 1 minus, as we saw in the previous slide, xd would become theta plus 2 times of y becomes 0. This would be theta square minus 3 theta plus 2 into y equals 0. This is a standard term which can be used to get the complementary function. So in this case we will not have any particular integral, as the right hand side of this ODE is 0. We will only have the complementary function. So when we solve this, we would get theta as 1 and 2, which are real and distinct roots. So y would be obtained as c1 e power the first root, that is 1, times z, since now we have changed the variable to z, plus c2 e power the second root, that is 2, times z. Substituting the value of z to convert the solution back to the format of x, we would get z is ln x plus c2 e power ln x. So this 2 that was here can be taken over as a power. This would give c1x plus c2 x square, that is the equation of a parabola. So substituting the first initial condition, that is y1 equals 0, we would get 0 equals c1 plus c2. This would be our first equation. The second equation would be, when we substitute y2 equals 2, will be 2 equals 2c1 plus 4c2. Solving 1 and 2, we will get c1 as minus 1 and c2 as 1. So y can be written as minus x plus x square. We need to find the value of y3. So substituting this value, we would get minus 3 plus 3 square, that would be 6. An ordinary differential equation was given where the coefficients were in terms of the variable x. Cauchy-Euler equation was applied to find the value of y3 as 6. The relevant NPTEL reference has been cited.